We track toxic air because we can quantify the damage to our lungs. But every few seconds, another form of invisible pollution enters our homes, through our ears, largely undocumented and ignored. India maintains strict legal noise limits and designates silent zones to protect hospitals and schools, theoretically buffering them from the chaos of the street. Yet the 2022 Central Pollution Control Board data from Bengaluru shows a massive disconnect. Monitoring stations inside these exact silent zones routinely record levels that drastically exceed safe limits, even in the middle of the night. Rules written on paper lack the structural mechanisms required to manage sound in a physical environment. Our current response is a reactive loop. A citizen complains, an officer arrives, the noise pauses, then returns. Conventional monitoring only captures loudness. Hitting 72 decibels gives us a number, but zero intelligence on what produced it. We struggle with noise because we treat it as a behavioral crime to be policed manually. In reality, chronic urban noise is usually the output of a system design failure. Meaningful change requires moving beyond punitive signs and adopting an urban quiet OS, a system built to diagnose and solve the root causes of the friction. The first layer of this operating system utilizes edge processing sensors. These devices record decibel spikes and extract acoustic features, but they delete raw audio instantly to ensure the system cannot be used for human surveillance. Layer 2 employs AI to classify the event. It distinguishes between a vehicle horn, a generator, or a siren, turning a raw spike into a category. Layer 3 adds context. It correlates that classified sound with real-time data like traffic light phases, queue lengths, or active construction permits. This combination of sound and context generates a specific urban diagnosis, pinpointing the exact conditions that trigger the noise. Consider an intersection where the OS detects a massive spike in honking during a specific red light phase. The system reveals the cause. The honking isn't from impatient drivers, but from a bus queue that physically blocks the left turn lane and traps vehicles. Instead of fines, the OS recommends a design intervention. Relocating the pickup zone and redrawing lane markings clears the bottleneck, eliminating noise at the source. Structural interventions eliminate the friction that causes honking, achieving a level of quiet that manual enforcement cannot reach. Once a redesign is implemented, the system enters a verification phase, measuring the afterstate to confirm a drop in acoustic events per minute. This creates a closed learning loop, ensuring that every infrastructure change is directly tied to a measurable improvement in the environment. The stakes are high. World Health Organization data links chronic environmental noise exposure to increased cardiovascular risks and cognitive impairment. Chronic noise exposure functions as a physiological stressor, forcing the body to absorb a burden that impacts everything from heart health to cognitive recovery. This data also exposes noise inequality. The heaviest acoustic burden falls disproportionately on vulnerable communities living near highways and industrial edges. A true quiet OS allows cities to simulate these impacts before a new flyover or hub is approved, using data to prevent noise inequality during the planning stage. Constant, abrasive noise marks a breakdown in urban design, the sound of a system that hasn't yet accounted for the friction of its own expansion. The objective is an intelligent urban environment where harmful noise is diagnosed, localized, and permanently designed out of the system.